In this lesson, we're going to be solving absolute value inequalities, but we're just going to focus on less than types of problems on this one. So, directions are going to ask us to solve. So let's take a look. So we'll have the absolute value of x is less than 10. So in order to solve an absolute value equation, we need to be looking for a couple of things. Is the absolute value isolated? Yes. And is this a positive value? If it's a negative value, we'll see what happens on the next problem. But absolute value is isolated, positive number. We are ready to break this into our two equations. So x is going to be less than 10, and then our second equation is going to have a negative applied to whatever is in the absolute value, and we'll solve that one separately. So there's nothing to do with this one, but on this one we'll divide both sides by a negative 1, and so x is going to be greater than, because we divided by a negative 1, it flips our inequality, and that becomes a negative 10. So before we write out, there's another way to write this answer. Let's get a little bit of a visual of what this answer looks like. So negative 10, positive 10, and we want x values that are greater than negative 10, which is an open circle, and our solutions are in that direction. This one, though, is our x's need to be less than 10, going in that direction. So they're going to overlap each other, and that's exactly what we're looking for. We want the values that overlap. So visually, we're looking at that. So our answers are between negative 10 and positive 10. So to write that, our solutions, our x's, are in that form. X's are in between negative 10 and positive 10. So that's kind of the standard version of it. This is a graphical version, and the interval notation is our solutions are going to range from negative 10 to positive 10, and we're not including those 10s, the negative 10 and the positive 10, so we use a parenthesis to represent that. And that is interval notation. Number 2. The absolute value of x is less than negative 10. So on this one, absolute value is isolated. However, we have a negative 10 here. And it doesn't matter whether it's an inequality, a less than, a greater than, or even an equal sign sitting here. As soon as you have a negative, it's going to change the way that we finish this problem. So on this one kind of becomes a logic. This is always going to be a positive value or 0. So are all positive values or any positive values ever less than negative 10? No. So there's no number we could plug into this to make it work. So it's a no solution. As opposed to up here, if we take a value in this range like 5 or negative 5, if we take a negative 5, it's in this range and we plug it in, the absolute value of negative 5 is positive 5, and positive 5 is less than 10. But nothing is going to be less than negative 10. So that's our solution for that. So let's do another. So the absolute value of x minus 3 is less than or equal to 6. So two questions are, is the absolute value isolated? Yes. Is this a positive value? Yes. Great. We are ready to set up our two equations. So x minus 3 is less than or equal to 6, and then a negative applied to the entire absolute value, also less than or equal to 6. So we solve each equation individually. Here we're going to add 3 to both sides, so x is going to be less than or equal to 9. On this one, we could distribute the negative in, but we could also just divide both sides by negative 1 to remove the negative. We'd have to divide by negative anyways at some point because it'd be distributed into the x. Might as well just do it right away. So we divided by a negative. That changes our less than or equal to a greater than or equal to, and this becomes negative 6. So same math, we'll add 3 to both sides, and our x's are going to be greater than or equal to negative 3. So visually, we are ranging from a -3 to a +9. And this time, because we have an equal sign in here, we're going to include the 3, the -3. And we want values that are greater than. And here we're including the 9, and we want values that are less than. And they overlap again. Perfect. That's what should almost always happen with the less than or equal to. So, to write this in a standard form, we're going to range from -3 to 9. So -3 is less than or equal to x, is less than or equal to 9. And interval notation, we're going to range from -3 to 9, but the difference here is that we're going to include the -3 and the 9. So we use brackets to represent that we're including those values because of the equal signs. So this is interval notation. All right, so let's do another. So -3 times the absolute value of x minus 3 again, minus 8 is greater than or equal to -14. So this problem is supposed to be a whole bunch of less than problems. This one's starting off as a greater than or equal to. We'll see what happens to that, of why this is in the less than group. First thing is we want to try to isolate the absolute value here. We want to get this by itself. So another way you can think of this is take that piece and just kind of make it its own variable. Let's call it a y. So if that were a y and we're trying to get that by itself, I would add 8 to both sides. So this would become -6, and this would be -3y. And then I'm going to try to get the y by itself by dividing both sides by a -3. So that y value we divided by a negative, which would make our inequality change, and a negative divided by a negative would be a positive. The math we did right there would be identical to how we get this absolute value by itself. So we'll add 8 to both sides. So that's going to be greater than or equal to -6. And then we'll have our absolute value, x minus 3, with a -3 in front. Now the -3 cannot distribute into absolute value. It's not quite like parentheses. Absolute values are a little bit more like walls. You can't distribute in. But what we can do is do exactly what we did over here. Instead of trying to distribute that in, let's get rid of it to isolate it. And let's divide both sides by -3. So those would go away, and you'd have an x minus 3, the absolute value of it, is, we did divide by a negative, so the greater than or equal to becomes less than or equal to, and that's why this is in the less than videos. So absolute value is isolated, and we have a positive. So since we have a positive, let's break it into our two equations. So we have x minus 3 is less than or equal to 2, and then we have a negative applied to the entire absolute value for our second equation, less than or equal to 2. So here, add 3 to both sides. X is going to be less than or equal to 5. And again, we could distribute that negative in because of the parentheses, or we could just divide both sides by a negative. So that would be an x minus 3. This inequality is going to change to a greater than or equal to. That'll become a -2. Add 3 to both sides, and x is going to be greater than or equal to 1. So let's get a visual. So we're ranging between a 1 and a 5, and we're equal to, so we're including the 1, we're including the 5, and we want x's that are greater than or equal to, and we want x's that are less than or equal to 5. And they overlap again. So our standard version to write this answer is we're ranging from a 1 to a 5. So our solution should be 1 to 5, including 1 and 5. And then our interval notation is our answers are ranging between 1 and 5, and we are including them. And if you ever get an answer and you want to kind of double check, you can always plug values in and make sure stuff works. So values between 1 and 5, a 2, a 0 should not work, and a 6 should not work. So you can always plug those values in and see if those things work. So if you plug a 0 into this, you'd have a 0 minus 3 is negative 3. The absolute value of negative 3 is positive 3. Positive 3 times times a negative 9 would be a negative 9 minus a 8. And this is not supposed to work. So negative 9 and a negative 8, or minus an 8, gets us a negative 17. And that is not true. Negative 17 is not greater than or equal to negative 14, so it doesn't work. So you do the exact same thing with the 2. Plug in the 2, and you should have a value that actually is greater than negative 14. And if you plug in a 6, you'd have a similar situation to this, where it's not going to be greater than or equal to negative 14. If you plug in 1 and 5, it'll actually equal the negative 14. So you can definitely check those. We'll do one more. So we'll do the absolute value of x plus 5 plus 6 less than 4. So everything looks good here. We have positives all throughout. We're going to try to isolate the absolute value. So we need to isolate this piece right here, which means we need to get the 6 out of there. So we'll subtract 6. So we have the absolute value of x plus 5 is less than negative 2. Absolute value is isolated, but we have a negative. So the negative is going to make us pause for a second and figure out what kind of a solution, because we're not going to have to do any of this. So absolute value is only going to be a positive, so nothing but positives are going to come out of this after we add 5, take the absolute value of it. So any positive is going to be less than negative 2, and the answer is no, so no solution. And then this was our interval notation on that last one. So that is solving absolute value inequalities involving less thans.